Hey everyone, let's go ahead and do the Unit 5, Lesson 11 Desmos problem set. Um, I've decided to work in the book today just to mix things up a little bit rather than doing it online. You can work in the book too, I guess, if you want. Just upload a picture to Google Classroom for your assignment rather than doing it on Desmos, student.desmos.com. So I'm on page 42. It doesn't matter if you work online or in the book, though. In my opinion, the questions are the same. Oop, page 42 I'm to write. So let's get to it. It says, select all of the expressions that are equivalent to 4 times 5 plus 3 times 5. So all we have to do is evaluate this expression, and then evaluate an expression just means like do the math and see what it equals. And then once we know what this one equals, we'll just evaluate all the other expressions and pick the ones that equal the same thing. So here you got to remember your PEMDAS or your GEMDAS, right? Let's do the multiplications first, and then we'll add last. So 4 times 5 is 20, and 3 times 5 is 15. So this equals 35. So let's just look at the rest of these and see which ones equal 25. In case you're confused about this, when you put a number right up against another number, and that one of them is in parentheses, and there's no other operating symbols between, like there's not a minus symbol or a plus symbol next to the parentheses, then that means to multiply. So this here says 7 times 5, which is indeed 35. So let's select that one. This one here says 12 times 5. Let me see if I can zoom in a little bit more. There we go. This one here says 12 times 5. That is 60. So nope, not selecting it. This one here, this says 7 times 2 times 5. You're supposed to work left to right when you have all, just straight multiplication across, but you don't really have to. You've got both the commutative and associative properties of multiplication that say, as long as nothing you're doing is anything but multiplication, doesn't really matter what order you do. And so for that reason, I'm going to do the easiest multiplication first, which is the 2 times 5 get me 10, and then times 7 is 70. In my opinion, that's an easier way of getting the answer than to do 7 times 2, which is 14, and then try to do 14 times 5. All right, here we got 10 times 5, which is 50. And here we got 3 times 5, which is 15. And when you subtract those, you do get 35. So let's select that one. And lastly, 3 times 5 is 15, and 10 times 5 is 50. Oh, it's the same thing, but they just switched the orders. If you've been getting kind of good at this integer stuff, you should know that if you take a subtraction and you just switch them like this, you get the opposite. Your answer turns out the opposite. So instead of 35 on this one, we're going to wind up with negative 35. And that's not equivalent to that one up there. So let's not select it. All right. Moving on, it says determine the value of the variable that makes each equation true. At some point, hopefully in your class, if you're in Mr. Wong's class, hopefully, I know in my class recently we've mentioned this idea of inverse operations. These are operations that sort of undo each other or do the reverse of each other. So like adding and subtracting, they do the reverse of each other. If you add 3 to a number, but then subtract 3 from that number, you just get back to where you started. And the same thing with multiplication and division. They're inverse operations of each other. They can sort of undo each other. Well, solving equations like this sort of relies on this idea of inverse operations. If you see a number being added and you want to work backwards to the variable, you subtract. If you see a number that's being multiplied, you can figure out what the variable is by dividing. Well, let's go and do it. Well, this one we don't really have to do that because the variable is all by itself. That's called an isolated variable, and that's going to be really important for us in our next unit. So this is an easy one. All we have to do is do 3 times negative 2.5. Well, 3 times 2.5 would be 7.5, but we got that negative in there, and so negative 7.5 equals x. So that's your answer there. Obviously, the next two get a little bit trickier where we need this idea of inverse operations. Here, I have negative 3 times some number equals 33. And so in my head, I'm thinking, okay, I know that if -3 times this number equals 33, then I can work backwards from there and do 33 divided by -3 to get the answer. It's the same relationship as like if I told you 3 times 4 equals 12, well, you could take the 12 and divide by 3 and get the 4, right? It's inverse operations. That's all we're doing here. We just don't know one of the numbers we're working with. And so I'm going to do 33 divided by -3 equals, well, 33 divided by 3 would be 11. But since we have one positive and one negative, the divisor here is negative, I should say. That's going to make our answer negative. And then anytime you do one of these equations like this, it's always a good idea to just check your answer. The way you do that is take the number that you think is the answer, in this case, -11, and put it where the variable goes in the equation. The technical name for what we're doing is called verifying our solution. And then see if it makes the equation work or if it makes the equation true. So is it true that -3 times -11, I'm putting it in parentheses now because it's a number. Whereas with variables with letters, you don't have to use parentheses. It's understood that a number next to a letter means to multiply. But once I put that number in there, I need the parentheses to say that I'm multiplying. -3 times -11 equals +33. That's a true equation. Negative times negative is positive, and 3 times 11 is 33. So our solution is therefore verified. It worked. Lots of times you'll see people put a check mark next to it when they after they verified their solution. We're going to be doing a lot more of this in the next unit. All right, and then the last one, let's see here. -3 minus 1/2 equals z. All right, so this is the type of question that I know a lot of students mess up because it's tempting to want to do 3 minus 1/2 and get -2 and 1/2 as your answer. That would be an incorrect answer. Instead, I'd prefer to think of it as -3 plus -1/2. Remember, you can always write subtraction as adding the additive inverse of the next number, the number you were going to subtract. And so I just changed that 1/2 to -1/2. And when you do that, it makes it more easy to understand that, oh, -3 plus another -1/2 is -3.5. It helps you avoid that mistake right there when you do it by adding the inverse rather than subtracting. All right, let's move on. I was just reading this part before I started this video and I'm like, is this real? Like, this feels like there's no way it could be real, but I don't know. I bet if I Googled it, maybe it is real. I don't know. So it says, on January 22nd in 1943, the town of Spearfish, South Dakota, that's really north in the United States, like where it gets pretty cold up there, set the record for the world's fastest temperature change. At 7:30 a.m., the temperature was -4 degrees. And then by 7:32 a.m., literally 2 minutes later, the temperature was 45 degrees. So it went from below zero, which is way below freezing, because remember, freezing for Fahrenheit is 32 degrees. It went from way, way, way below freezing to like 13 degrees above freezing in 2 minutes. That sounds fake to me, but I don't know. I guess I'll believe it because it's in the book. All right, so question 2.1 says, how many degrees did the temperature change each minute from 7:30 to 7:32? And make sure to show whether it was positive or negative. Oh, if you're in my class, you probably already know that I live next door to a trombone player, and from time to time you get that background sound. So enjoy the background music. All right, so first let's figure out how much total the temperature changed from -4 to +45. Like, let's figure out what that equals. And there's formulas for doing this, and you can kind of just do it with a quick subtraction if you know what you're doing. But I'm going to do it this way instead. I'm going to draw a little number line to like help myself. You're going to have a question just like this on this test coming up later this week. And so this is the way I would handle that question. I'm going to put 0 on the number line somewhere. And then -4 is somewhere around here. I don't need to be like perfect, and I don't need to make little marks for every number. I just kind of have to get a feel for where everything is. And then +45 is like way over here. And so the temperature started here and it ended here. And now I can just kind of use this number line to help me figure out, okay, well, to go from -4 to 0, that's a +4 jump. So I'll write a +4 there. And then it went even more up from 0 to 45. That's another +45 jump. So the total jump from start to end is just these two jumps put together. 45 plus 4 equals 49 degrees. So, but we're not done. That's all we did there is we figured out the total jump. And then it says we want to calculate the change each minute or change per minute. And I like that word per because if you're in my class, I've said a million times that the word per just tells you to divide the first thing by the second thing. I'm reading this as change divided by minutes. And so, okay, well, here's a change. We just figured that out. That's my change. And the minutes, well, looks like 2 minutes, right? 7:30 to 7:32. So I'm going to do 49 divided by 2. And I get, well, this is how I would do this in my head. 50 divided by 2 is 25. I can do that pretty easy. So I'm just doing one less than that. So I just got to take 1 divided by 2 off my answer, which is a half. So instead of 25, it's going to be 24.5. And I'm indicating that the change was positive by not putting a plus or minus sign on it. Like just leaving it blank is a positive change. If it was a negative change, I would throw a negative sign on there. All right, let's move on. So I'll box that. This is my answer here. All right, and so the next one says, how many degrees did the temperature change each minute from 9 o'clock to 9:27? Make sure to show whether the change was positive or negative. All right, let's go back up to the information. 9 to 9:27. It looks like at 9, the temperature was 54 degrees. And then at 9:27, it was all the way back down to -4. So in the course of 27 minutes, right, 9 to 9:27, the temperature went down, I mean, a lot. We got to figure that out first, right? But from 54 to -4 in 27 minutes? Can you, 54 degrees, I like the cold. I'll stand outside in shorts in 54 degrees. Just imagine if you were standing outside for 27 minutes and then all of a sudden wearing shorts and then it was all of a sudden -4 degrees. All right, I don't know. This is just kind of blowing me away. So I'm going to draw a similar number line thing like I did in the previous question. And so I'll put 0 around here again. And this time I'll put +54. And there's a little bug crawling on my thing. Can you see him? There he is. Hey, bug. Oh, I didn't mean to bop you. Sorry. So there's my +54. And here's my -4. And so let's figure out the total change the same way. Let's figure out like how many jumps or how much of jumps would we have to do to get from, well, from here to 0, that's a -54 jump. And then from here to here, that's another -4. Oh, we got bugs crawling on the paper. We got the trombone guy in the background. I hope you're able to focus. All right, so really all we have to do is just combine these two things and we have the total change. This is 54 and this is 4. They're negatives, but the cool thing about when you're adding numbers that are all negative, you can just add them as if they're positive regular numbers and then throw a negative sign on your answer. So really I'm just going to do 54 plus 4 equals 58. But really I have -58 as my answer. Okay, Mr. Bug Guy, I think it's time to get out of here. Come here. I don't want to hurt him, but I don't want him in my way either. All right, so now we figured out the temperature change over that course of 27 minutes. Sorry, my handwriting isn't very good here, but this is supposed to be a -58. I'll write it again, more clear. And so now we want the temperature change per minute. I like the word per better than each. Okay, so we're going to do the change divided by the minutes. Negative 58 divided by 27. I bet if you're working in the Desmos like online thing, you could probably just make the fraction negative 58 over 27, and it would give you credit for that, I think. I mean, I suppose we could divide this in a calculator, but I feel like it's going to give us a crazy decimal. I'll give it a shot. Let's see here. Where's my calculator at? So I'm not going to worry about the negative off top. I know my answer is going to be negative. So let me just do 58 divided by 27 equals, yeah, I mean, do they want you to enter all those decimals into the thing? Did I mess this up? Like, yeah, even teachers feel that way sometimes. Like when you get a crazy answer like that, you start to second guess yourself. Like, am I wrong? Let's see here. No, I have the answers here in front of me. So, I mean, it's right. I would just enter it as the fraction negative 58 over 27. I wouldn't worry about that. What was that? 2.14 something. Yeah, I don't know. Let's just call it negative 58 27ths. And so the negative sign there is indicating that the change was downward, right? The temperature was decreasing during that time. All right, then this last question is borderline silly to me. I don't understand the point of them asking this one. It says, what is the diff? Okay, I'm gonna get rid of Mr. Ant guy here. Get out of here. It says, what is the difference between the temperature at 7:30 and the temperature at 9:27? Go back and look at the info. It was -4 at 7:30 and -4 at 9:27. So there's no difference. I don't know if they're just trying to give you a trickster question or what. I mean, I guess one piece of math value I could get out of this is that the way you're supposed to calculate these answers is by doing a thing called the distance formula, which is the absolute value of one of the numbers minus the other number. So this is like the higher level way of like finding these answers rather than doing like jumps on a number line. And so I've got -4 minus -4 in absolute value bars. Well, this equals the absolute value of -4 plus 4, because minus a negative is the same as plus a positive, right? Anytime you're subtracting, you're allowed to change that minus to a plus, but when you do that, you have to make the next number the opposite, right? It used to be negative, so now it becomes positive. Well, -4 plus 4 is 0, so this just becomes the absolute value of 0, which equals 0. I'm not really sure why they wanted us to do that one, but whatever, we did it. All right, we're gonna review some percent stuff here. If I can get this thing set up the way I want it, I suppose that's good enough. All right, it says if you buy a pair of shoes on sale for 10% off, and the sale price of the shoes is $40.50, how much did the shoes cost originally? Let me show you how to do this question incorrectly first. It would be incorrect if you thought, oh, okay, well, 10% off the price got me $40.50. Let me just figure out what 10% of $40.50 is, and I'll add it back on, right? If you were to just go, okay, well, 0.10 times $40.50, that would be $4.05. And so then I'm just going to do 40.50 plus $4.05 equals $44.55. That would be incorrect. And the problem with that is you're finding 10% of the sale price and tacking it back on. But the 10%, when they took that 10% discount from the price, it came from the original price, some bigger number. And so that 10% is bigger than $4.05. If I had to guess, it's probably more like $4.50, somewhere around there. In fact, just looking at it, I think that's probably actually going to be the answer. I think it's going to be I think it is going to be the 10% discount was $4.50, but let's check it. So the way you should do this instead is thinking of it as, well, 10% off. That's the same as taking a 100% original, subtracting 10% off and getting 90%. That's the percent we really care about. Let's think of not as it being 10% off, but as it being 90% of our original price. And we'll think of this as our new price or our part, whatever you like to think of it as. And so the formulas say that if you have a part, which in this case would be the $40.50, and you divide it by the percent that it is of the original, like how big of a piece it is, that will get you back to the original or the whole amount, whatever word you want to use. And so that's what we're going to do. Let's just take that part, the new price, $40.50, and divide it by 0.9, right? Because 90% equals 0.9. So let's do that. Let's see here. I'm going to take $40.50, divide it by 0.9. I feel like this is going to come out to $45 because the 10% was $4.50. Let's see that. I could be wrong. 40.5. Okay, I don't need that last zero, right? Divided by 0.9 equals, yep, so it's $45. That's going to be our answer there. All right, and then it says if there's sales tax of 6.5%, how much will the total cost of the shoes be? So we're not going to use the $45 from the previous question because that's a whole like non-sale price that we're not paying. We're paying the $40.50. And I want to multiply that by some number that's going to get me the price plus an additional 6.5%. So first, let me convert this to a decimal over here. 6.5%, that equals 0.065. I moved the decimal point over 2 spaces, 1, 2, and I had to fill that empty gap with that 0. If I were to multiply $40.50 by 0.065, I would get 6.5% of it. And then I could take that number and I could add, and I would get the right answer. I don't want to do 2 steps like that, though. I'd rather multiply by 1.065. Because what happens now is when you multiply the $40.50 by the 1, that gets you $40.50. Like it keeps the price in your answer for you. And then the $40.50 times the 0.065, that tacks on the sales tax for you, tax on the tax. And thus like you get the final answer all in one calculation rather than having to do 2. So I'm grabbing the handy dandy and I'm doing 40.5 times 1.065, and that's going to equal that $43 and 0.1325. With dollars, you always round to the nearest second decimal, the hundredth spot, because there's 100 pennies in a dollar, right? Or 100 cents in a dollar. Certain things in life, they will charge you even smaller than a penny, like a decimal of a penny or a fraction of a penny. Sometimes you see it at gas stations on the signs outside. It says that like maybe a gallon of gas is $3.59.999 or whatever, like there'll be an extra decimal point. If you're into cryptocurrency like Bitcoin, stuff like that, those things are down to fractions of cents when you buy and sell those things. But most things in life we just round to the nearest second decimal. So it was $43.1325. I'm going to write it as 43.13, because since that third number is a 2, I'm going to round down. If that third number had been like a 5 or up, I would have rounded up. You just make sure that Desmos is rounding that same way. Let me see what they put as the answer for that one. Yeah, they put the same thing. All right. So all we have left is these puzzles in the Explorer. So let's do them. So in this puzzle, wait, I can't see my own screen here. I'm all messed up. What happened? Yeah. Well, let me move this stuff. So the first puzzle, the one with the zeros in it, your goal is to make all these equations equal 0, right? Okay, well, in the top row here, I see 4 divided by something and then times something equals 0. Well, I know a little fact or a little math rule that says you cannot divide by 0. You're not allowed to do it. There's no such answer, or a mathematician would say that that operation is undefined. And so I know I cannot put a 0 here. But in order to make this a 0, the only way you can get a 0 through multiplication is if you're multiplying by 0. So by process of elimination, that has to be a 0. And now this could be pretty much anything at this point, because no matter what we put here, when we multiply it by 0, we're going to get 0. So we'll have to come back to that box and figure it out later. So let's try going down here. I've got 0 plus something, and then plus something, or no, sorry, then plus 2 equals 0. Well, this is already a 0. This needs to equal a 0. So the only things that are actually going to add up are in these two boxes. If I've got a 2 and I want to make a 0, I want to add a -2. So this is about additive inverses now. All right, now let me try looking here. I see that something times 2 minus -2 equals 0. Remember that minus -2 is the same as adding 2. So what I have here is 2 minus -2. This whole thing right here is going to equal 4 if I leave it the way it is. I don't want to put a 0 here because based on PEMDAS or GEMDAS, if I put a 0 here, I'll get 0 times 2 and then minus -2 equals +2, because you do the multiplication first here. So instead, my strategy is to try to switch this 2 to be negative. Because if this 2 right here were negative, then I would have -2 minus -2, which equals 0. Any number minus itself equals 0. And I can switch this 2 to -2 by multiplying it by -1, right? That's tricky. -1 times +2 makes a -2, and then -2 minus -2 equals 0. All right, let's see here. Which one should we do next? It looks like the only ones we have left are both left in this column, but I'm pretty sure I still cannot figure out what goes in this box until I figure out what goes in this box. So I need 4 divided by something, and then plus 2 equals 0. So I need the result of this division to be a -2, because then when I add +2 to it, I'll get 0, right? Well, 4 divided by -2 equals -2. So I needed it to be a -2, and it also just so happened that in order to get that, I had to divide by -2. So, all right, here we got something plus 2, and then minus -2 equals 0. So this is literally the exact same scenario as, oh no, it's not quite the exact same scenario, because here it was adding, and this is, or here it's adding, and here it was multiplication. Okay, so we just need to add something in this box to 2 minus -2 in order to get 0. Well, 2 minus -2 is +4. So if we just add a -4, we get 0. And we don't really have to care about this line anymore, because we're just multiplying by that 0 to get that 0 at the end. Ah, that was pretty tough. All right, let's do that last one. So rather than fully complete this last one for you, I think I'm going to just give you some of the some of the operations, and hopefully that'll make it easier for you to try to complete on your own from there. So I'll tell you that this right here is supposed to be multiplication. Okay, that's not the letter X, it's not a variable, it's times. Okay, and then in the second row, I'll tell you that this one right here is supposed to be subtraction, and this one right here is supposed to be division. Then in the next row, I'll tell you I feel like I might have some of these wrong. I feel like I'm gonna mess this up. Let's hear. Oh, no, I didn't. No, I didn't. All right, so in this row, I'll give you that this right here is a division. In this row right here, I'll give you that this is plus and this is minus. And in the last row, I'll tell you that that's a plus. All right. So I'll just be straight up honest and say I was copying that from the teacher book because this looks pretty challenging. I'll be perfectly honest. Let me make sure. Oh, I haven't even been looking at my screen. Can you see what everything I'm doing? Yeah. But now that you have the majority of it filled out, right? You just got to figure out 1, 2, 3, 4, 5 boxes, and there's no equations left where you don't at least have one of the operations, right? You can do this operation here, figure out what it equals, and then that should help you figure out what goes here, right? -4 times -1. That you should be able to figure out what that equals, and then that should make it a lot easier to figure out what sign goes here. So there, I didn't leave you with any spots where there were 2 empty blanks in the same equation because that's really challenging. So give it a try now. See if you can finish it from this point. All right, I'll see you.